Tennis. Okay, it's pong. It's really just pong. This is the third game in the IBM PC Junior Entertainer, and it's the shortest game in the book at about 70 lines. All right, let's play. First, let's change line 510 so that I can control it with a single joystick. So instead of stick 3, which is the y-axis of the second joystick, I'll use stick 0 so that I'll control it with the left and right x-axis of the first joystick. Also, let's change line 610 so that we only have to go to a score of 3 instead of 15 to win the game. Okay, here we go. So I'm just tilting my gamepad sideways to control the other player here. Now, notice when the ball is hitting into the edges or into the paddles. Whoops. Notice what happens with the color of the ball. Well, that's not very good. Oh, okay. All right. Well, we're tied up 2-2 now. So you'll notice that inside of a paddle, it changes blue, and on the edge of a wall, it's actually changing to a cyan color. And that'll become important later. All right. Now, let's take a look at some game issues. The book emphasizes an optimization of moving up and down with a single line of code, line 370. Also line 510 for the second player. Here's how it works. I is the previous position of the paddle, and then it subtracts this Boolean condition here, which is comparing the joystick y-axis is greater than Q down. So if you're holding down, and I less than 164, so you're not too far down. And then it adds this condition, which is if the joystick is less than Q up, so you're holding up on the joystick, and I greater than 25. You haven't gone too far up. So it essentially takes the old position and then either adds 1 or subtracts 1, basically. And unless if you're not pressing on the joystick at all, then it'll just be, these will both be false and they'll turn to 0. So it's supposedly an optimization because the movement is all done in a single line, but it actually takes another line, at least when the paddle is moving, to add 6 pixels to move 7 at a time instead of 1. If you look at line 390, this multiplies, h minus I, that could be a -1, 0, or 1, multiplied by 6. So it adds another 6 pixels or subtract 6. So really it ends up making the code harder to read, and it still takes 2 lines, and it's not any noticeably slower to just use the straightforward code, which would just be like, if stick 1 is greater than Q down, so we're holding down, and I less than 164, we're not too far down, then H equals I plus 7, so we move down 7. And then we could do a similar thing if stick 1 less than Q up and I haven't gone too far up, I greater than 25, haven't gone too far up, then H equals I minus 7. So they could have just written it the easy way, but I mean, it's interesting. It's cool that you can do it on a single line of code and make use of Boolean, and the fact that a Boolean changes to an integer. But here's the funny part. The book takes 6 paragraphs to explain how line 370 works. But it's all backwards. For example, it says if the variable I is increased, the racket moves up. If the variable I is decreased, the racket is moved down. That's backwards. I was reading that and I got very confused because, coordinates are such that 0 is at the top and 199 is the bottom. So it just didn't make any sense to me. Well, the reason it's all backwards is because of this. So what is 3 greater than 4? Turn to an integer. 0, false, right? That's expected. What about 4 greater than 3? You might expect this to be 1 for true. Well, it's -1. So the explanation in the book is written as if true is 1, which it is in plenty of languages, but in BASIC, true is -1, not 1. So that's how we end up with a backwards explanation. Okay, next thing is on line 720. Let's look at 710 to 720. Here the book had a T2. I fixed it to a T1. It's showing the player's score at the end of a game. It shows how many times each player has won. Well, T1 is where it keeps track of how many times player 2 has won, but it had a T2 here. And that would result in player 2 number of wins always showing 0. So don't be player 2. Next thing, this doesn't hurt anything, but the paddles overlap with the red edge by 1 pixel. So they might have wanted to adjust this, but on the top edge here, you can see that this paddles are going over by 1 pixel. So that's where you see here like a bright green color. So again, doesn't hurt anything. Also, I fixed this already, but the right edge of the wall was 6 pixels too short. So over here, it didn't line up. You actually had some blue right there. And that was just on line 220 and also line 240. This had a 299 here and here. So again, doesn't hurt the game. And in fact, I didn't even notice it until my son pointed it out. But if you look at the right side here, that doesn't extend all the way there. Next nitpick, there's an unused variable on line 150. Here it defines p and b as integers. And p is used, but b is actually never used anywhere. And then also on line 360, here it gets the x-axis of the first joystick, assigns it to D, which is not used anywhere. Again, remember the game uses the y-axis, not the x-axis, except in this version where I temporarily modified it so I could control player 2. But, this might be intentional. I don't know if there's an issue where maybe in some joysticks you have to look at the x-axis first to initialize it. So, I mean, it's possible. It's entirely possible. So, all right. Now, here are 2 interesting features of the game implementation. First, the usage of on error to trigger a score. Take a look at line 350. On error, go to 580. And then line 580, here begins the lines of code for updating the score. So why does an error event indicate a score? Well, it happens when there's an error trying to put the ball outside the bounds of the screen. Let me show you what I mean. Here, we can put the ball in the top left corner of the screen. Now, what if instead of there, what if we tried to put it at off the screen at -1? Okay, sorry. This is really funny because I'm trying to illustrate the problem, but it just ran into an error, and so it ran. It started running the middle of the code. It did the go to 580. Okay, let me turn this. Okay. On error, go to 0. That'll turn off that behavior. Okay, let's put a ball on the screen. Okay, now let's try putting it at a negative, so it'll be off the screen. So illegal function call. So similar thing on the right side. Let's put it at 300, and let's put it in the middle. And now let's change it to 310. Okay, that's all right. Here, we'll just put it off the screen like 320. So illegal function call, so that's an error. So as it tries to paint the ball, draw the ball on the screen and it can't, it's an error, then it jumps to the score, updates the score. And the second interesting game feature is how it checks that the ball has hit a paddle or an edge. If you'll remember earlier, I mentioned how the ball changes color when it's hitting a paddle or an edge. So let's look closely. So it turned blue inside the paddle, and then inside the wall it turns cyan. So here, let me show a little better here. Let's just put it at 180, 40. That should be maybe 30. No, 15. Okay, so here you can see that it's cyan. So it's using the point command to check the color inside the ball. And the color changes when it's put on top of another object or other colors on the screen, because put defaults to XOR. So the colors are getting XORed together to result in new colors. If you look at line 490, this is where it's checking that if using the point command, x plus 2, y plus 2, that's the middle of the ball. If that's 11, which is the cyan color, then q equals negative q, so that's reversing the direction of the ball. If we look at line 500, and this is saying if the middle of the ball is 1, which is blue, and that was the color inside the paddle, then p equals negative p, so it can change this direction, the x direction. This is also where it sets up some randomness in how, the q, how much of a vertical velocity to have. So, okay. Now let's take a look at an emulator issue. I'll reproduce the problem again by adding a line 185 to set the color to 15, 0. Now that's a white foreground color with a black background color. Let's see what this looks like. Okay, this is what I was greeted with when I ran the program the first time. It happened because the palette was getting reset on the screen command, resulting in a black background, the default, instead of blue, and foreground color of white instead of gray. And when it paints the ball, it's expecting a gray outline, but the ball is getting drawn with the default foreground color, which ends up being white instead of gray. So then the white paint escapes and paints the whole screen white. It's drawing the ball just using a circle, just a 2-pixel radius wide circle, and the game is setting the default color to gray, so it should have a gray outline, so then it can paint inside of here with a white and a gray outline. That's what's expected. Anyway, I was really confused because I had already patched the emulator, and I was actually unable to reproduce it in interactive mode when I was, running these commands directly. Running the screen command was not. Let's say I have a color back to cyan. Running the screen command was not resetting any palettes interactively, but when I ran the program, it was. I was really confused. Anyway, when I undid I just resaved my patch. I just resaved the file and it started working again. So it had somewhere cached the old version, I think. But anyway, when I undo my patch, it messes up the background color again, so we end up with the black. But the foreground color remains fine. So I'm actually unable to reproduce this paint issue. I was unable to reproduce that, except by manually adding this line like I showed. Okay. Now I want to show you what the game looked like before I added in some delays to get it running at proper speed. But first, I want you to listen to the original sound. It was just using beep. Okay, beep. I changed that to sound 350, 2. All right. A lower, shorter. Okay, compare. Beep. Sound 350, 2. I found this one a lot more pleasing, but let's put in the beep here, and then also let's take out the main. We'll just take out the main program delay that I put in. So, all right, let's see what this looks like. Oh crap! Yeah, this is what I was greeted with. It was the messed up colors and the fast. It was so awful. Okay, let's load the. Let me just load it, and then we'll put the beep on here, and we'll put the get rid of the main program delay. Okay, here we go. So yeah, this is what it's like trying to play. Anyway, you can see that's somewhat annoying. But anyway, and then as far as any bugs encountered while programming due to typos, I actually didn't introduce any bugs while typing it in that I know of. Well, there was one or two, but that I noticed and fixed right away as I was glancing back and forth. So let's finish off by showing the smooth mode and how I made this work. So here is the smooth mode. Here you can see that the game is actually a lot smoother. And the way I made this work was I took the a few lines of code. So on line 390, here I got rid of, remember, added 6 more pixels to move 7 at a time. So I just put, times 0. So this line effectively does nothing. And then on lines 430 and 440, I added a divide by 7 here so that the X and Y moves 1/7 of the distance that it was. And on line 4020, this is the main program delay. I changed this from 2000 to 250, so about 8 times faster. And yeah, so that's how we got smooth mode. And yeah, this smooth mode is really quite playable and fun. Actually makes it quite a bit more fun. So now let's see if I can get someone else to play with me. All right, you ready to play some Pong?
Mm-hmm.
Okay. You want the smooth version?
Yes.
Okay. And let's get rid of the delay.
Mm-hmm.
Because it's too easy on when it's slower, so we need to go a little faster.
Yeah.
Also, let's change the max score so that we only go to 3 instead of 15.
Yeah.
Okay. All right, you ready?
Mm-hmm.
Let's go. Let me get this mouse pointer out of the way. What? That's not fair. I was moving the...
You get good.
Get good? What? But that hit my paddle. I swear that hit the paddle. Who wrote this game? There, take that. I hope the ball doesn't get stuck inside of your paddle. Oh boy. Oh yeah, I'm gonna get this way.
Nope.
Oh, you lucky. Do you like how it uses the color of inside the ball to check if it hit something?
No.
You don't like that?
Yep.
Oh!
GG's, I win.
Alright, you win. Thanks for playing.
Yep.